So we are in lesson 1.3, arithmetic with real numbers. Now this section is going to be very, very easy for some, and maybe just a bit of a review or a reminder to others. So it makes it a little bit difficult as you go through here to know what to go over and what to realize that most students know. So arithmetic with real numbers, we're going to just do addition, subtraction, multiplication, and division of real numbers, which are things that you learned in first and second grade. But we're going to put the negative number spin to this, so it's going to make it not more difficult, but a little different. So if we've got a number like 5, and then we add 7, you know from elementary school that that equals 12. But sometimes you're going to run into a number like 5, and you're going to subtract a larger number from it. And what do you do with 5 minus 7? So there are a couple different methods as far as adding two real numbers. And this works whether you're adding numbers like 5 plus 7 or 5 minus 7. So we're going to change that 5 minus 7 because the 5 plus 7, you already know how to add those. But 5 minus 7, we're going to change it to an addition problem. So we're going to take that minus, make it a plus, and put that negative on the 7. Okay? So now we're adding, but we're adding a negative 7. So whenever you're adding two real numbers together, you take the difference between the numbers, and we're not going to worry about whether or not they're positive or negative. We're just going to look at a 5 and a 7, and we're going to take the difference between those two numbers. What's the difference between 5 and 7? A difference of 2. And then we're going to put the sign of the biggest number on our answer. So there's a negative on the 7. 7 is bigger than 5, so we're going to put a negative there, and we're done. That is a way that I was taught to do this many, many years ago, back when numbers were first invented, and always works. So whenever the signs are different, you take the difference between 5 and 3, and put the sign of the largest number on there, and you're done. And that is the way that you solve problems with positive and negative numbers. Now, if both of the numbers are positive, obviously you don't do anything except just add the two numbers together. If we were to have a negative 5 plus 3 like we do, we get negative 2. But let's make a little bit of a change here. Let's make that a negative. So we have negative 5 minus 3. Well, we're going to change it to a plus and put the negative on the 3. Now, the rule I just gave you was if the signs are different, you take the difference and put the sign of the largest number on the answer. If the signs are the same, you just add the two numbers together and put that similar sign on the answer, and you're done. It's just like 5 plus 3. The signs are the same, so you add them, and you put the sign of both of those numbers on your answer. In this case, it's a positive 8, and you don't even have to show the positive number. And I did the exact same thing on this one here. The signs are the same, so I add the 5 and 3 together and get 8, and put the sign that's common to them, the negative, on the answer. And that is pretty much it. Now, lots of books will teach you all kinds of different ways to do them. And if you like doing other ways that maybe you were taught, that is just fine. As long as you're following mathematical rules, you'll be okay. So a negative 7 minus 6. Again, we're going to change that to a plus, negative 6. Signs are the same, so we're going to add and put the sign on there, and we're done. If I had negative 7 plus 6, signs are different. I'm going to take the difference, put the sign of the largest number on there, and there I go. So let's look at one where we have a couple different negatives on here, like 9 minus negative 2. Whenever you have two negatives side by side, change them both to plus. 9 plus 2 is 11. Okay? Negative, let's do negative 6 minus negative 5. Signs are side by side. We're going to change those to plus then. Signs, now I've got two numbers. Signs are different. I'm going to take the difference between 6 and 5, sign of the largest number on there, and I'm good. Okay, so let's jump over to multiplying real numbers. Multiplying is so much easier than adding and subtracting. So multiplying is a little bit more enjoyable. So here's how it works. If you have two numbers that you're multiplying that have the same sign, doesn't matter what the sign is, if they're the same, the answer will be positive. Two negatives give you a positive when you multiply, two positives gives you a positive. If the signs are different, you will always get a negative. One of the things I teach students is look at the number of negative numbers being multiplied. Okay? If there is an odd number of negative numbers, your answer will be negative. So for instance, if I'm multiplying 3 times negative 2 times negative 6 times negative 3, I've got 1, 2, 3 negative numbers, so my answer is going to be negative. So I don't even have to worry about making sure everything's negative and positive and doing all that. I just go 3 times 2 is 6, times 6 is 36, times 3 is whatever, 108. Well, I already decided, I think 108, check me. I've already decided it's a negative answer because I have an odd number of negatives and I'm multiplying. So I don't even have to worry about the negative anymore. If I have an even number of negatives, my answer is always going to be positive. So then I don't have to worry about the negatives at all. They can just go away. 3 times 2 is 6, times 2 is 12, times 4 is 48. And I know it's positive because there were 1, 2 negative numbers. And that just makes it so much easier. You just count the negatives, and then you've got the sign, and you don't have to worry about the negatives anymore. So to me, that just makes it so much easier, so much less that I have to deal with. All right, jumping up to page 34. Now we're going to divide real numbers. And there is some theory to do all of this. And I don't necessarily think that you need to understand all of the theory, but let's just look at it real quick. It says that if we have 6 divided by 3, that is the same as taking 6 times 1/3. Because this 3 is in the denominator, it's still there, but it can't just be there by itself, so there has to be a 1 up there. And so 6 times 1/3 takes you right back to the 6/3, which reduces to 2. And it's the same with negatives and positives as it is in multiplication. If you have a negative and a positive, your answer will always be negative because we have an odd number of negatives. So an odd number of negatives gives you a negative answer. If I have an even number of negative numbers, my answer is going to be positive because I have 2. Okay, so that makes it real easy again to determine whether your answer is positive or negative, and you just basically you're reducing or dividing that fraction. Same thing. All right, so example 7 on the bottom of page 34. Let's go ahead and write that down there. Negative 2 minus 3 times 5 minus 9. So again, PEMDAS, as we're going to do in the parentheses. So we're going to change that negative 2 to a plus negative 3. Signs are the same, so we add them together and put the sign on there. Okay, so that is the answer to this part. Let's look at the 5 minus 9. So let's do 5 plus negative 9. Signs are different, so I'm going to take the difference between the 5 and the 9 and get 4. The negative sign is on the largest number, so that gives me a negative 4 there. So the negative 4 is what I get when I solve that part. So what am I doing to what's in the parentheses? I've got this being -5 and this being the -4. And what do I know about an even number of negatives when I multiply? I'm going to get a positive, and I just multiply the 5 times 4 and get 20, and I'm done. All right, let's look at example 8. And I like that they give all these examples. It just really helps you to get it a little bit better. 2 minus 5 times the quantity. 7 minus 4 minus 6. So I'm going to do in the parentheses first. I'm just going to leave everything else the same. 7 minus 4 is 3 minus 6. PEMDAS says after we do parentheses and exponents, we do multiplication. So we don't do anything with the minus sign, but we do multiply that. And now all we have left is subtraction. 2 minus 15 minus 6. Well, let's change those to plus signs. And let's look at this one first. 2 plus -15. Well, the signs are different, so I'm going to take the difference between the two and put the sign of the largest one there. And I still have the plus -6. I haven't done anything with that yet. So now I'm going to do these two. -13 plus -6. Signs are the same. So I just add the two numbers and put the negative sign on there. So the key is if the signs are the same, you add the numbers. If the signs are different, you take the difference between the two numbers. So hopefully that'll kind of help you to know what you're doing there. Okay, so let's just keep moving along here with example number 10. We've got 6 times t over 3. Now remember, it doesn't matter what that letter is. We're not going to do anything with it. It just stays there. It's just like an x or a y. So what does that say? It means, well, let's make this into a fraction. Multiply the top number. Multiply the 1 times 3. And we get 6 over 3t. Now we look at 6 over 3 and that reduces. What is 6 over 3? 6 over 3 is 2. And the t stays the same. We didn't do anything to the t. It was on the top here. It's on the top here. And it's on the top here because the fraction would look like that. So because it's in the numerator, it will always stay in the numerator. Now let's look at number 11. It's a little bit trickier. 3 times t over 3 minus 2. So we're going to distribute. 3 times that is going to give me 3t over 3 minus 3 times that, 6. Okay, so we can reduce things because if we look at our numbers here, can we divide those out? What is 3 divided by 3? 3 divided by 3 is 1, so we don't even have to put the 1 in front of the t because it's always an assumed 1, and we didn't do anything with the 6. So this is the simplification of that. And then we're done and ready to move on. So the next examples are more complicated fractions, the book says. Well, let's see if we can make them a little bit easier. So let's look at number 12. We got -8 minus 8 all over -5 minus 3. All right, so let's just look at the top and then we'll look at the bottom. And one of the things I want to bring up now, and I will continue to bring up for the semester, is this division line, or some people call it a fraction line, separates everything up here from everything down here. That means you do everything you can up here and everything you can down here before you cross the line. You don't cross this line until you've got everything as simple as possible. So let's look at the top here, -8 minus 8. So I'm going to change that again to a plus -8 before I do anything. And down here, I'm going to change that to an addition. Okay, so now I'm going to look at my numerator. -8 plus -8. Signs are the same, so we add them and put the sign on there. Okay, on the bottom, signs are the same, so I add them, put the sign on there. So this is my simplified version of this but it can be simplified even more. Because two negatives, we have an even number of negatives, so that becomes positive. So my negatives go away. 16 over 8 is 2. So it changed to a positive 2 there, and we're good. So let's look at one like number 14, because that one's a little trickier, but really isn't any harder. You're just doing the same thing kind of over and over. We've got 2 cubed plus 3 cubed. All over 2 squared minus 3 squared. So what we're going to do, according to PEMDAS, we're going to do parentheses, which there aren't any, and the next step is exponent. So we're going to do the exponent. So 2 times 2 times 2 is 8, plus 3 times 3 is 9, times 3 is 27, over 2 times 2 is 4, minus 3 times 3 is 9. Okay? This is not negative 3 times negative 3. You ignore the sign. You just take the number and square it. Leave the negative sign alone. All right, so now we start combining. 8 plus 27 is 35. 4 minus 9 is the same as 4 plus negative 9. Signs are different, so we take the difference between 4 and 9 and put the sign of the largest number on there. And we have one negative, which is an odd number, so I know my answer is going to be negative, and I take 35 divided by 5, and that is 7. And we're done. Okay. So I'm going to go ahead and make a second video on this lesson. Not a whole lot to go over, but I just want to stop it now before it gets too carried away.